Today we'll be reviewing Learning Target 7.1. I understand when data fits a normal distribution and how to display, interpret, and compare data on a normal curve. We will also be exploring z-scores and how to use our green percentile table. First, let's start with a warm-up. This is some data about the shots taken by the Blaine hockey team per game. It follows a normal distribution with a mean number of shots of 27 and a standard deviation of 6. So right now, I'm going to ask you to pause the video and sketch the curve in your notebook. So now let's check our work. So the mean always goes in the middle. You've got 27 and a standard deviation of 6. That's what we're going to count by. So up by 6 gives us 33, 39, and 45. And with that, we want to include our z-scores. They are 1, 2, and 3 with our mean in the middle. And then counting down gives us 21, 15, and 9. That would be -1, -2, -3. So this is what we learned yesterday. So now let's talk about some questions we can ask about this data. We learned this empirical rule, the 68, 95, 99, 7 rule. And that says within 1 standard deviation of the mean, 68% of your data will lie. Within 2 standard deviations of your mean, 95% of your data will lie. And within 3 standard deviations, 99.7% of your data lie. So now I want you to pause the video again, and there's 3 questions that I'd like you to answer. So take a moment and see if you can answer these questions. Okay, let's see if we got the right answers. Between 21 and 33 shots. Those are within 1 standard deviation above and below. And our empirical rule says that 68% of our data lies within those 2 values. What percent are between 9 and 45? Well, those are your plus and your minus 3. So that would be 99.7%. And this third one was a little tricky. What percent of games are higher than 39 shots on goal? So if we look at where 39 is, kind of erase some of this here. Here's 39. We want to know this little tail right here. And so since it's around that +2, I know that 95% of my data are between 15 and 35, which means I have 5% split up evenly between the 2 tails. So half of the 5 is over here and half of the 5 is over here on the left side. So what percent are higher than 39 shots on goal? That would give me 2.5%. So now we're going to take a look at a different kind of a question. And this question says, what percent of the time does the hockey team take less than 30 shots on goal? Now the problem with this number here is that it's nowhere on our scale. It's not any of our 7 numbers under our z-score scale. So where is 30 exactly? If we look at our scale, here's 27 and here's 33. 30 is exactly in the middle. So we want to know what percent is in this red portion of my curve. Well, 30 is exactly in the middle. And so yesterday we talked about how a z-score of 1 means you added 1 whole standard deviation. You added 6 to get from 27 to 33. So if we're halfway between, we added 3, my z-score should be about 0.5 or half of a standard deviation, half of that 6. Now, it's easy to see on this slide, but it's not always going to be quite that easy to figure out the z-score. So let's take a look at a formula that we can use to find the z-score. This is our z-score formula. You're going to want to draw a box around it or highlight it because this formula is something you're going to be using from here on out. And what it says is this: the z-score equals x, that's your data, minus x bar, that's the mean, all divided by the standard deviation. So, if we want to find the z-score using this formula for our data on the previous slide, it would look something like this. Z equals your data, 30, minus the mean of 27, all divided by 6. That's 3 divided by 6. And that's how we get our z-score of 0.5. So we can use this formula every time, regardless of whether it's easy to see the z-score or not. So now, let's take a look. There's a little typo, let's fix that. Does our z-score of 0.5 make sense? Does it match up with what we thought? And yes, it should. We added a half of a standard deviation to get from the mean, 27, to our data point, 30. So now, here's where we're going to look at those green z-score sheets. And we're going to learn how to look up the percentage on that green sheet. Our empirical 68, 95, 99, 7 rule really only works when we're dealing with a data point that is exactly 1, 2, or 3 standard deviations above or below the mean. When we start getting decimal z-score values, or any z-score value for that matter, we need to use this green sheet. The green sheet, people have done the math and they've figured out the area and the percentages on and filled in this table. So our goal today is to learn how to read that. So you should be looking at this sheet. Notice it has one side that says positive z-scores and the other side says negative z-scores. Each of the blackened numbers refer to a z-score. Each of the white or gray 4-digit decimal values, those are all percentages. So what we'll do is we'll look up the z-score and we find a percentage. The one thing that you need to note is that with these z-scores and percentages, every single one of these percentages, and I'll highlight them so you know exactly what I'm talking about, all of the percentages on the z-score tables, these are all below the z-score. They're called percentiles. Percentiles refer specifically to a percent of the data that falls below a specific number. So for example, we're talking about percentiles. A percent we're familiar with as a raw number. You get a certain percent on your test. What the percentile does is it says, how did you do compared to others? So for example, Maggie is in the 90th percentile for her GPA. What does this mean? It means that Maggie scores higher with her GPA, or Maggie's GPA is higher than 90% of her peers. In other words, she's in the top 10% of her class. She has a pretty good GPA. Some other examples would be like this. I've got 3 sons. 2 of my sons, generally as they've grown up, have been either in the 99th or the 87th percentiles for their weight and their height. So we have Jesse and we have Nathan. So generally this means that they're pretty big compared to the other kids their own age. It's always compared to other kids their own age. So Jesse's 99th percentile, he's probably going to be a linebacker on the football team when he grows up. Nathan is 87th. He's just going to be a tall kid. He'll be above average. Now my other son, my youngest son, he's on the smaller side compared to his brothers. Andrew has only been in the 5th percentile for his height and weight. So he's only bigger and taller than 5% of other 2-year-olds. So he's on the smaller side, he's below average. Anything below the 50th percentile would be considered below average. So 2 of my boys, well above average, Andrew, below average, but still growing and doing just fine. So now let's go back to our green sheet. You should be looking at the side that says positive z-scores. We are going to look up a few z-scores before we do our hockey example, just to get the hang of it. So the first question is this: what is the percentile for a z-score of 0.83? So here's how we're going to look this up. If you notice across the top here, so I'll try my best to highlight it so you can look. You've got some 2-digit decimals, and down here along the bottom, you have some single decimals. Notice it starts with 0 point something, and it goes down, and it goes all the way to 1 point, 2 point, 3 point. We know that beyond 3 standard deviations, we don't have a lot of data, so your z-score table really only goes up to about 3 point something. When we're looking up a z-score, we always start on the column side. In other words, the up and down portion. We're going to come and find the 0.8. If our z-score is 0.8, we're going to look for that part first. This is found in the column. The 3 is in the row along the top. So if I'm looking at 0.8 right there, this column here would represent 0.80. The next column would be 0.81, 0.82, and finally, the third column, 0.83. So I'm going to go all the way over to that column and find that value, 0.7967. So what this means is if I have a percentile of 0.7967, approximately 79.67% of the data falls below that z-score, whatever the z-score is for. That's what that means. If I was looking at a normal distribution, it would be the part of the curve shaded, if that's 1, 0.83 would be here. It would be this part of my curve. That would be about 79.67%. Percentiles from the table are always below your z-score. So what I'd like you to do right now is pause the video, and I want you to look up a z-score of 1.1. Keeping in mind that if it doesn't have a second digit, you can always think of it as z equals 1.10. So locate that on your table, put your finger on it, and then check in with a neighbor and make sure you've located the right number. So pause the video and do this now. So if z is 1.10, we find 1.1, and then the 0 is the second digit, so 0.8643 should be the percentile that we found. That's the percent below a z-score of 1.1. Now let's flip it over to the negative side. So we need to be careful on the negative side, because as you'll notice across the top, it starts at 0.09 and goes backwards. So this would be like a z-score, if we're looking at the first row, of negative 3.49, negative 3.48, and so on and so forth. So something you can write at the top, and I encourage you to do this. I want you to write a note that says, be careful, it's backwards. So that's a little note and reminder to yourself to be careful how you look things up on the score sheet on the negative side. So let's do the first one together. Negative 2.83. I'm going to scroll down to the negative 2.8. I'm going to look those digits up first. Negative 2.8. And then I'm going to go all the way over to the 3 column. And there's the percentile for negative 2.83. And it should make sense that it's so tiny, 0.0023, because if we think about where it is on the normal curve, here's your mean, here's 1, 2, negative 3. Negative 2.83 is somewhere right around in here. So you're finding this percentage right there. It's always below 0.0023. Now, pause the video, find negative 2.9, and check in with your neighbor. Negative 2.90, be careful, it's not 0.0014, it's all the way over here, 0.0019. So now that we're used to using the sheet, let's go back to our hockey example. And we're going to look up our z-score of 0.5. So we're going to go to our z-table on the positive side, 0.50 if it doesn't have that second digit. 0.50, where do they intersect? And here we are, 0.6915. That's this area here. That's the percent of the time that the Blaine hockey team takes 30 or fewer shots on goal. So now here's one for you to try on your own. What percent of the time does the Blaine hockey team take less than 20 shots on goal? So take a moment right now and do these two following things. Find the z-score for 20, and then look that up on your percentile table. Pause the video right now and try that. Make sure you check in with your neighbor before checking your answer with the video. So the z-score I get is 20 minus 27 divided by 6. It's a negative z-score of negative 1.16, which we can round also to negative 1.17. And when we come down to our z-table to look up negative 1.17, we get about 12.1%. So now here's my follow-up question. If 12.1% is this area here, what percent of the time do they make more than 20 shots on goal? So now the whole curve adds up to 100%. So anytime we want to know more than a value or higher than a value, we're going to take the 100% and subtract the answer from the table. And that's going to give us our answer. 87.9% of the time. So again, less than the number, you take your answer from the table. More than the number, you have to subtract from 100. So now, here's another one to try on your own. The average score on a stats final is 71, and the standard deviation is 6. If you score an 84, what percentile are you in? Take a moment right now and do the following things. Use the z-score formula, find the z-score, and then look it up on your percentile table. Pause the video and try that now. The z-score for our data will will look like this. 84, that's your data, your score, minus the mean, divided by the standard deviation. This gives us a z-score of about 2.17. So, when we look this up on our table, 2.17, we get 0.9850, which means you are in the 98.5th percentile. You did better on your final than 98.5% of all of your peers who also took the final. That's what this means. So what I'd like to do right now is take a look at a new example. Joe Mauer hits home runs with a mean distance of 397 feet and a standard deviation of 10 feet. Suppose his home runs are normally distributed. Sketch the curve below. Let's do this one together. His mean will go in the middle, up by 3, down 3, and I will label my z-scores. So find the probability that Joe hits a home run that goes 405 feet or farther. So let's think about this on the curve. 405 feet will be kind of around here. It's not quite, it's a little more than halfway. Now, our table value will give us this percent. But that's not what we want to know. We want to know 405 or farther. We want to know this part right here. So we're going to have to subtract our answer from 100 before we give our final answer. But first things first, let's find our z-score. We're going to take our data, 405, minus the standard deviation, minus the mean, divided by the standard deviation. So we're going to get a z-score of 0.8. So take a moment right now, pause the video, and look it up on your z-score sheet. When we find it on our percentile table, we should get a percentile of 0.7881, or about 78.81%. But remember, if we want to know the other side of the normal curve, we need to take 100 minus 78.81%. So when we do that subtraction, we get 21.19%. A little over 21% of the time, Joe Mauer will hit a home run that is 405 feet or longer. That's how we answer those questions. This is where the lesson will end as far as z-scores and the normal distribution and using your z-score table go.